In this example problem, we're going to do another hypothesis test. The only way this one is different than the previous ones we've done so far in Chapter 6 is that in this particular hypothesis test, the variable that we're testing for isn't quantitative, it's qualitative. It's returned yes and no, which means we don't have a scale for our returns. It's not going to be measured in number of dollars, number of hours, etc. It's going to be measured in something that's qualitative. In this case, yes or no. Now the procedure is incredibly similar, but we have to use some slightly different calculations because now we're not looking for a actual mean, we're looking for a proportion. So in our situation right now, we have that driven by the growing public support, the legalization of marijuana in America has been moving at a rapid rate. A health practitioner in Ohio collected data from 200 adult respondents assessing whether they favored marijuana legislation or not. In this file, we have the results of that questionnaire that was asked to 200 residents of Ohio. We're going to use that to perform a hypothesis test to determine, with a 10% allowable chance of a type 1 error or a 10% significance level, whether overall for the entire portion of Ohio, is there a difference in the number of people that favor legislation than the going national average of 68%? Why would this be useful in a business setting in this case? It's huge business. I was typing this, recording this in 2024. These things are popping up all over the place. It's a multi-billion-dollar business, and while a good number of states have ratified legislation to legalize the recreational use and sale of marijuana, not all states have. And if you are in Ohio, which at the time of recording is a state where it is not legal, then you would really be interested in, is this going to pass if this comes up to a vote or not? Because you have the opportunity to preemptively make plans to establish your business to satisfy this desire of consumers and capture your market share before another competitor does. So we're going to do a hypothesis test in this case to figure out, is there something different in Ohio that's going to lead us to having a smaller portion of the population say yes to legalization than there is across the whole entire country, where everybody else has been slowly legalizing the recreational use and sale of marijuana. So what are we going to do in this case? Well, same steps, just slightly different calculations, because now we're working with a proportion. So we need to find our population proportion. What is the population proportion? It's the entire percentage, in this case, of the overall American population that has been in favor of legalization, which we have right here given as 0.68. So we have our P. We need the size of our sample. Well, we know right here that we collected data from 200 adults. I, again, could just confirm that I have all of them in my information by using the count A function to count all of my respondents, Control-Shift down to shortcuts. And yep, we have 200 respondents in the sample. How many of those respondents said yes? So now I want a count of how many there is, but if and only if they said yes to the questionnaire. So I can find that using the COUNTIF function. So equals COUNTIF, open a parenthesis. First thing I'm going to input is my range. And my range that I want is all of the returns that we have in column B, whether they said yes or no. So I'm going to start with the very first one, Control-Shift down to grab all of them. I got cells B2 through B201 now. Scrolling back up to the top. And then the second thing that I need is the criteria that I want to count. Well, I want to count the number of people that said yes. And you have to put it in quotation marks. So in quotation marks, yes, and then close the parenthesis. And when I hit enter, that COUNTIF function is going to tell me that in column B, 124 people said yes, they were in favor of marijuana legalization. So what is the proportion of our sample that said yes, or our P hat, P bar, or whatever you want to call it? It is simply the number of people that met the criteria divided by the sample size. So 124 divided by 200 is going to come out to be 0.62. 62% of our sample said that they were in favor. We're going to assume that we have normal distribution. We could do the sample of 200 people over and over and over again, and most of the returns would come somewhere around the population average. to figure out what that amount of variance that we have in here, we're going to find the standard error for this proportion. And to do that, you got a bit of a formula right here. What you need to do is say that it's equal to the square root, SQRT, open a pair of parentheses, of the population proportion, so 0.68, times the complement of that. So in another set of parentheses, I'm going to say 1 minus 0.68. And if you're good with mental math, that's the other 32%, if you will. And then we're going to divide that by the sample size. And our sample size was 200. And now I got to close two parentheses to close everything out. Thank you for color coding those Excel, so I know I have all the parentheses in there that I need. So one more time, your standard error is the square root of the proportion times its complement in this pair of parentheses divided by the sample size. And it comes out in this one that we have a standard error of about 3.3%. Now, to find my z statistic in this case, I'm going to fill in my inputs that I just calculated. It's going to be equal to, open a parenthesis, our p hat, our sample proportion, which is 0.62, minus our population proportion, the national average of 0.68. And I just moved off the spot, there we go. Close that parenthesis. And then I'm going to divide that by the standard error that we're working with, which is 0.033. And when I do, I come up with a z statistic of negative 1.8190, which is implying, in this case, that we think based upon this information in Ohio, the return is going to be about 1.8 standard deviations below the national average. So what is, in this case, our one-tailed probability? Well, for all hypothesis tests that you do with a proportion, it's fair to assume that your returns are going to be normally distributed. Very rare scenario that they wouldn't be. You're going to assume that we could do this poll of 200 people over and over and over and over again, and the returns from any 200 people are going to be pretty concentrated around that center point, your population average. So what is our one-tailed probability? Well, now I don't want a t-distribution. What I want is a normal distribution. So I'm going to type in norm.dist, norm.dist. And after I have that, I'm going to go. And it's the very first return that I have. And it's going to ask me for some inputs over here. The first one being that x is the number that we are using, the statistic we're using to test for the probability. In this case, that's going to be our z statistics. I'm going to click cell E7 to get that negative 1.8190. For the mean and the standard deviation of a proportion that you have over here, you're always going to put the same two inputs in, 0 and 1. And then the last thing that we have at the bottom is cumulative. Do we have a cumulative distribution right here? And you are free to assume in this that that is 100% true. Because the more and more we go, the more and more our distribution is going to continue to gather around this central point. It's going to accumulate. And when I do that, I come up with, rounded off to 3 decimals, 0.0345. We have one issue right now, though. That's just a one-tailed probability. What is our alternate hypothesis? That we think the true population of all of Ohio is going to differ from the 0.68 national average. Now, it's just differ. It could be lower or it could be higher. And this one tail is only accounting for the probability of one of those sides. So we're saying here we've got like a 3.45% chance that it's lower and a 3.45% chance that it's higher. Well, what's the two-tailed probability then? If it's 3.45 on each side, it's just double that. So I can say it's equal to this times 2. And again, I rounded off, so it's going to come out to something that's just off by like a 10,000th right here, just because I'm rounding to a certain decimal place. I got 0.0689. Saying right here that our probability, in this case, that we say that in Ohio, the proportion of people that would favor legalization of marijuana differs from the 0.68 average. If I make that claim, there's a 6.89% chance of a type 1 error. That I'm going to make that claim, get more information than just these 200 people right here, get a more accurate, larger sample set, and realized that I rejected the null hypothesis when I should not have, because there really wasn't a true difference from the 0.68 national average. So what is the allowable level that we're giving ourselves, the significance level? We said 10%. We are going to make this claim, the alternate hypothesis being is truer than the status quo of our null hypothesis. We're going to make this claim only in this case if we think the chance of having a type 1 error is less than 10%. Well, what's our chance of having a type 1 error according to our two-tailed probability? Well, let me put it in percentage mode over here just to make it 6.89%, which means our p is less than our alpha. And when p is less than alpha, you reject the null hypothesis in favor of the alternate hypothesis. So what we're saying right here is we honestly believe that in Ohio, the proportion of people statewide that favor marijuana legalization is not equal to the 0.68 national average. Now, could be less, could be more. I'm assuming from the sample being 6 points lower, more likely than not less, but we'd have to do further analysis to figure that out. But we're safe to assume that there's something different in Ohio or it's not lining up with the national average. Does that mean that we should go into business starting this thing? Well, I'm certainly not investing millions of dollars to start up based upon 200 results we have right here where we have a sample proportion that's below the national average. But we have a starting point right here that we can assume that just because 68% of the people in other states are feeling this way, it doesn't mean that we have information right here to say that 68% of people in our state feel this way. We reject the null hypothesis in favor of the alternate hypothesis, and we truly do believe that the true proportion of all Ohioans that favor marijuana legalization is not equal to the 68% national average.